Section 15.9 on spherical coordinates. So suppose you have the regular XYZ axes and then you need to locate this point right here. So in theory, you could have a sphere where the center is at 0 and you know the radius and you draw a sphere and that point would be on it. That's the general idea behind it. Let's be more specific. So if you measure the distance from the origin out to that point, that is called rho. So the rho equals the distance from the origin. Now, the only problem with this is I don't know what direction this line really is going. So what you do is you drop this down to the XY plane. You find out where it hits the XY plane and you draw a line to that. So this line right here is in the XY plane, and then you measure the angle from X over to that line. So that tells you what direction to go to find that line. And then that is called theta. So the theta is measured from the x-axis. And then you need to know how far down this angle is. So from the z-axis, you then measure to where that line is, and then that angle is phi. So phi is the angle from the z-axis. And then you would get to that point right there, and it's labeled as the rho goes first, and then the theta, and then phi. Now, how do you convert between x, y, and z and our new system? So you use these formulas right here. So x is the rho times sine of phi and cosine theta. Then y has sine and sine, and z is just the rho times cosine of phi. And it's basically made with, you make a right triangle in here, there's a right triangle in here, there's a right triangle right here, and you make 3 little right triangles and do basic trig, opposite over hypotenuse and things like that. And because of these trig functions, it turns out when you have x squared plus y squared plus z squared, it equals rho squared. That is the equation for a sphere. Thus, the name. Now, when you go to integrate, well, remember when you do polar, you have to multiply it by an extra r times dr? Well, in here, in order to integrate, you need to multiply by an extra rho squared sine of phi. So each integral, when you set it up, is going to have that little extra bit right there. Now, let's start doing some examples. So for example number 1, suppose you had x squared plus y squared equals 1, and then convert that to the spherical coordinates. So x squared, so you replace x with the rho and sine of phi and cosine of theta, and that's going to get squared. Plus, you replace y with rho, sine of phi, sine of theta. That gets squared, and then it equals 1. Then everything needs to be squared, so that's going to be rho squared, sine squared, phi, cosine squared, theta, plus rho squared, sine squared, phi, sine squared, theta, equals 1. And then we need to simplify this. So notice that This has rho squared and this has rho squared. Also, there's sine squared and sine squared of phi, so those things could be factored out. So factor out rho squared and also sine squared phi. And then what's left is cosine squared theta plus sine squared theta. You're right, that does equal 1. So this part equals 1, which means that we just have this. And then it still equals the 1 on the right side. And to simplify it, we could even take this square root. And I could even divide. So in other words, rho equals 1 divided by sine. Actually, I was going to put cosecant, and I think I will at the end, but actually I would stop right there, because if this is the function that you're supposed to integrate, so instead of having to integrate this function, we're going to be integrating this function, and then you would put that right here, and then it would be multiplied with this, and then this sign and that sign would cancel. So even though it looks like it was a mess, it actually turns out that it will really help simplify. Or you could just say 1 over sine that is equal to cosecant. Then for example number 2, trying to get one piece of paper and all 5 of them want to come play the game. Then for example number 2, now the other way around. So this is going to be rho equals 2 cosecant phi times secant of theta, and then change that to have x's and y's instead of rho and all that other stuff. Well, for one thing, I could change this to 1 over sine, and I could change that to 1 over cosine. So it's going to be 2 on the top, and then this will be 1 over sine phi, and this will be 1 over cosine theta. And then I could take this and multiply both sides by it. So then the left side would have rho multiplied with sine phi cosine theta, and then it equals 2. But then that looks familiar. That's this one right here. So it has the rho, the sine, and this one. The rho, the sine of phi, and the cosine of theta. So that means it's x. And so it turns out that it's just x equals 2. So sometimes it might be more complicated with this system, and this system is more simpler. Or it could be, like the last one, instead of having to integrate this one, it would be simpler to actually integrate that one. So you need to be able to convert back and forth between the two systems. Speaking of integrating, let's actually integrate something. Example number 3. Find the volume between these two functions. Z equals the square root of x squared plus y squared, and that is a cone, comma, x squared plus y squared equals 4, that's a right circular cylinder, and z equals 2, and that's a plane. So just a quick sketch of what's going on. So there's a cone, which goes like this. Nice circular top on the top of the cone, but the edges go straight up. And then there's a right circular cylinder with a radius of 2. So if you go out to 2 on the x-axis and the y-axis, and then make a nice circle, then that circle is going to go up until it hits the cone. And then z equals 2 means stop it where z is equal to 2. And then we're supposed to find the volume inside here. So it's this volume in here that we're finding. Okay, so now as far as the row, so it has to be able to go from here out to this region out here and capture this volume that's right there. And the farthest it's going to go is when it hits this cylinder. So that is going to be the row right there. So in other words, the row needs to range between 0 and the x squared plus y squared equals 4 shape. And what is this? So then we need to substitute what does x equal and what does y equal. So x squared means rho sine of phi cosine of theta gets squared. Y squared means that it's rho sine of phi sine of theta, and that gets squared, and then it equals 4. And then we need to simplify this. So there would be rho squared sine squared phi cosine squared theta plus rho squared sine squared phi sine squared theta equals 4. And like previously, we could factor out the rho squared and the sine squared. Oops, phi. And when you factor it out, it's going to leave cosine squared plus sine squared, which is just a 1. So you could put times a 1. And then it equals 4. And we could take the square root of both sides. So rho times sine of phi is equal to 4, or rho is equal to 4 over sine of phi. So that's saying that it's going from 0. What does rho range between? It ranges between 0 and this function right here. Okay, now we're ready to set up the triple integral. So triple integral. And because we're finding volume, we don't have any extra function to put right here, so we go straight to that extra rho squared sine of phi that all of these spherical coordinates will have. And then I'm going to go d rho d phi d theta. And then for this one's limits, that's what I just figured out here. It's going to go from 0 to 4 over sine of phi, and then phi. So remember the phi goes from the z-axis to the shape. So since we're talking about this shaded over area over here, then it's going to go from this red line until the bottom right here. Well, because this came from z equals the square root of x squared plus y squared, so that's basically like if you were to graph y equals the square root of x squared, so that means the absolute value. And in that case, this is 45 degrees and this is 45 degrees. Or in other words, pi over 4. So this red line, that angle would be pi over 4. So it's going to start when it gets to pi over 4. And then it's going to need to go down until it hits the ground or the y-axis, which is in the ground. And then that's going to be pi over 2. And then finally for the theta, so you have to measure that from the x-axis, and since it has to go all the way around this circle, then it needs to go from 0 to 2 pi. Okay, so we've done the hard part, setting it up. Now, just for the fun part, integrating. So first of all, integrate with respect to the rho, which means this is going to be rho cubed over 3. And then the sine of phi will just stay there as a constant. And then evaluate from 0 to 4 over sine of phi. And then later we'll have d phi and d theta. Just recopy those limits of integration. So first of all, we need to cube this. So that's going to be 4 cubed over sine cubed. And this 1/3 right there, I'm just going to factor that out. Okay, so I factored out the 1/3. I substituted this and it got cubed. And then it's still times another sine phi. And then when you substitute 0, that would mean subtract 0. And then we would have the d phi and the d theta. So one of these signs is going to get canceled and it's just going to leave 4 cubed over sine squared. So 4 cubed is 64. You could factor that out, 64 thirds. And then what's left is 1 over sine squared. And 1 over sine squared, that means that it's cosecant squared. And then what's the antiderivative for cosecant squared? Well, the derivative of tangent is secant squared. The derivative of cotangent is cosecant squared with a negative sign. So this is, the antiderivative is negative cotangent. And then that gets evaluated from pi over 4 to pi over 2. And now that there's no theta stuff left in here, we could go ahead and do the d theta separately. The antiderivative of d theta will be theta. That needs to be evaluated from 0 to 2 pi. And then don't forget about this 64 over 3. So it's going to be 64 over 3, and then negative cotangent of pi over 2 minus negative cotangent of pi over 4. And then this will just be 2 pi divided 2 pi minus 0, so that's just going to be 2 pi. And then how much is cotangent of pi over 2? So tangent of pi divided by 2 actually doesn't exist because that is going to infinity. Well, cotangent is 1 divided by that, so that's going to equal 0. And then negative, negative, so tangent of pi over 4, that's a 1, so this is 1 over 1. And these two negatives will cancel, so it becomes plus a 1. And so the final answer would be 2 pi times this, so that is 128 pi over 3. And now spherical coordinates, example number 4. Evaluate this integral. So it's going to be x squared times dv, or in other words, over the volume. And the region E is between this, the positive square root of these things, and y equals the positive square root of these things. Notice if on this one you square both sides, you could then add x squared and add z squared, and you would have x squared plus y squared plus z squared equals 9. So this is a sphere with a radius of 3. Because this is only the positive square root, it's only the top half of the sphere. Likewise, this is a sphere of radius 4. But again, only the top half. So you've got a sphere with a radius of 3. Nice round shape. And then you've got this sphere that's got a radius of 4. And then we're talking about in between these two. And then it's only the top half because of the xy plane. And then set up the integral. So we'll have triple integral. Then we need to replace x with rho sine of phi cosine of theta. The direction said x squared, so that needs to be squared. And then when you're changing to spherical, you need to also add in an extra rho squared sine of phi. And then we'll go d rho, d phi, d theta. So for the rho, so that's measured from the origin, and then as you go out to get to this region, so you would go out until you get to a distance of 3, and then it would start calculating the volume, and it would go from 3 until it gets to 4. So the rho is going to go from 3 to 4. Then for the phi, so it's going to have to go from here until it gets all the way down to here, so that it's going to be the top half of a circle. So that would be from 0 to 90 degrees, or from 0 to pi over 2. And then the theta, it could go all the way around, so that would be from 0 to 2 pi. So that basically sets it up, but I was just wondering, could we simplify it a little bit just for extra fun? Yeah, let's do that. So this has rho squared and rho squared, so that's going to be rho to the 4th. This is going to have sine squared and another sine, so there's going to be sine cubed phi, and this is going to be a cosine squared, and then that takes care of all that stuff. Then there would just be d rho, d phi, d theta, and then the triple integral. And it was just set it up, so that one's finished.